Hey guys, welcome to your 4.2 notes on patterns and linear functions. By the end of the day, you'll be able to identify and represent patterns that describe linear functions. Let's get started with some definitions. So we're going to look at some graphs today, and you notice that some graphs have a horizontal axis. Horizontal means it goes side to side, and you have a vertical axis. Vertical means up and down. So when we're talking about variables, there are two kinds of variables. We have independent variables, and independent means it doesn't depend on something else. It doesn't depend on the other variable. The independent variables are represented on our horizontal axis. They go side to side. So our independent guys, they go right here on our horizontal axis, usually called the x-axis. And those are things that we will put into our function, and then what we put in there gives us a value that comes out. So we call these inputs. So it's really convenient that the independent variable is your input. So we'll come up with a mark to put here, and then that'll give us a value here. So when we input something, that'll give us an output. That output is going to depend on whatever your independent variable is. So since it depends, we'll call it dependent. And I like to represent them in green. No particular reason, it's just consistency. So the dependent variable will change depending on what your independent variable is. This is all kind of abstract, and we'll get into more detail in a little bit. So the dependent variable goes on the vertical axis. It goes up and down, and we call those outputs. So I've been using these words a lot. Let me do some examples. We'll just do 2 examples, and then we'll call it a day. Okay, so let's start out with some rectangles. I have this wonderful diagram for you, and we want to figure out the relationship between the perimeter and the number of rectangles represented. Remember, the perimeter is the distance around a figure. So if we look at this guy, we've got one rectangle. And when we have one rectangle, the perimeter is going to be 6 plus 1 plus 6 plus 1, which is 14. So its perimeter is 14. Nice. So that's if we have one rectangle. When we have 2 rectangles together, the perimeter is 6 plus 6 plus 1 plus 1 plus 6 plus 1 plus 1, which comes out to be 16. So this perimeter is 16. And then when we have 3 rectangles, the perimeter is 6 plus 3, I'm just going to call this 3 plus 6 plus 3, which is now a perimeter of 18. Whew, nice. Okay. So the first step when you figure out any problem is you want to define what your variables are. You want to figure out what are we talking about here. Well, in order to do that, we need to look at what the relationship is. It's asking what's the relationship between, and that will tell you what your variables are. So the number of rectangles and then the perimeter of the figure. Those are the 2 things that we're looking at. Those are the 2 variables, the things that change. So as the number of rectangles increases, you'll see the perimeter also increases. But also, the perimeter depends on the number of rectangles you have. So our 2 variables are going to be our independent variable, which is the number of rectangles, because we can change that as we want to. But the perimeter of the figure will depend on the number of rectangles we have. So our dependent variable is the perimeter. Okay. So there's our first step. We defined our variables. And once we have our variables defined, actually we didn't pick a variable, just kidding. We just looked at what we're talking about. So defining variables means we need to pick a variable to go with it. Now for the purposes of this class, your independent variable will almost always be x, and your dependent variable will almost always be y. If you wanted to, you could say, oh, let's pick N for number of rectangles or P for perimeter. But to keep things easy, we'll just say that's X and perimeter is Y. Okay. It's also very important to define your variables so that you remember what they represent at any given time. And you're not just like, well, X, was that number of xylophones? What? Okay. So now we've got our variable straight. Let's make our table. So our table will give us an X value and a Y value. And for design's sake, let's do a little quick color coding so remember what's what. X is the number of rectangles and Y is the perimeter. Cool. So I did X and Y. If you want to change your table and say, oh, that's number of rectangles, that's fine. Or Y is perimeter. That's also fine. Okay? In fact, we already did the math, so I don't need this space. Sometimes when I'm making a table, I'll put a huge space between them so I can do the calculations, but we already have our information. So let's just plug them right in. Okay, when we have one rectangle, the perimeter is 14. When we have two rectangles, the perimeter was 16. And when we have three rectangles, the perimeter is 18. Yay! Cool. We made a table. That's it. Okay, now words. Let's describe this using words. So what do we see? Well, as X increases, X is going up by 1 each time. As X increases by 1, the perimeter increases by 2. So you could say, start with 14, and as the number of rectangles, that's not technically a word, but we're going to count it. As the number of rectangles increases by 1, the perimeter increases by 2. Some of you might have noticed the pattern. You know what? The number or the perimeter is going to be the number of rectangles you have, but times 2, and then you need to add 14. Some of you are really good, no, so you don't add 14, you need to add 12. Some of you are really good at finding patterns like that. You just say, you know what? Start with the number of rectangles you have, and then each time you add 1, you need to add 2 for your perimeter, so that's where that 2 comes from. Except to get our original one, you needed to also add 12. That's the equation. I don't really know how to tell you how to find the equation better than what I just did, but that's okay. If you need help finding patterns, I'll work with you in class. And then finally, we had table, words, an equation, and now a graph. So here's our graph. Here, maybe I'll do this. Table was number 2, words, equation, graph. Now, for me, graphing is my favorite part because we know what we need to do. We know that our independent variable will go horizontal because independent always goes this way. And then our dependent variable will always go vertical, up and down. And we need to label our axis. We need to know what we're talking about. So let's look at the x's that we're dealing with. We go from 1 to 3. So I'm going to label these as 1, 2, 3, 4. Yeah, why not? But we also need to say, hey, what does x represent? X represents the number of rectangles. So we label our axis down here like that. Same thing, we need to look at the perimeter that we're dealing with. Since y represents the perimeter, put it here. Or if you wanted, you can rotate it like this way. That's fine too. And our perimeter goes 14, 16, and 18. So we have 5, 10, 15, 20. That'll fit. Excellent. So we label these. Oh no, come back. We label these as 5, 10, 15, and 20. Now, when we have one rectangle, we're going to use our table here to help us graph. When we have one rectangle, the perimeter is 14. So I'm going to go over 1, up 14. And when we have two rectangles, our perimeter is 16. So over 2, up 16. And when we have three rectangles, our perimeter is 18. So you go over 3, up 18. Nice. And that's our graph. If you wanted to notice the pattern there, you could totally make a line and then connect them. However, a line doesn't really make sense on this graph because you can't have like half of a rectangle to add on. But the line does help you predict what will the perimeter be when you have 4 rectangles or 5 rectangles. So there you go. Hey, look, we did it. The most important thing is define your variable so you remember what they're talking about and label your axes, you guys. Okay, cool. So that's where independent and dependent variables are important. Now, let's get some new definitions in there. Let's talk about functions. A function is a relationship that pairs each input value with exactly one output value. That means for every x you put into a function, you'll get just one y out of it. When you hear relationship, when you hear function, just think rule. What's the rule? What's the pattern? I like rule. Rule is my favorite. What's the rule here? You might have seen in elementary school these little function boxes, right, where you've got this little machine, you know, and you put something inside of it. You put an x into the function box, and then you turn the gear, and then out will come a y value. That's exactly the picture that you should have in your mind. When you're talking about functions, think it's like a machine. If you put something in, you'll spit something out when you're done. That's exactly what that is. Okay. Now we have one very special kind of function. A linear function is a function with the shape of, you guessed it, a line. So if they all make one line, then it's a linear function. And the way that you determine if it's linear is you graph it and you say, hey, is this a line? You say, yeah, it is. Cool. All right, done. Yeah. Okay, so let's do one more and then we'll call it a day. So the table here shows the relationship between the number of photos you take and the memory left on your device, your memory chip. Is the relationship linear? Describe the relationship with words, an equation, and a graph. Okay, so we've got our table. Yay. Let's zoom in on it. Now, in order to describe it with words, let's see what's happening. What's the change here? Well, here, each time it increases by 1. Here, our x increases by 1 every time. And our y doesn't increase. In fact, it decreases. It decreases by 3. And that should make sense, right? As you're taking photos, you're losing memory. So they're taking up space. Okay. So to put this into words, you would say, as the number of photos increases by 1, the number, gigabytes? Megabytes. The number of megabytes left decreases by 3. But we left out a very, very important part. That's describing the change. We don't know how much we have to start with. So, you start with 512 megabytes. Okay. that's one way to describe this rule in words. It's kind of verbose, it's wordy, okay? Another way to describe it is you can say, the amount of memory left after taking X number of photos is 512 minus 3 times the number of photos taken. The number of photos taken. I think that does technically have less words. They both work. Personally, I prefer this one. The amount of memory left after taking X number of photos is 512 minus 3 times the number of photos taken. Great, huh? Well, now that we have that in words, that will help us write an equation. So we know that y is the amount of memory left. So we say y equals, and then what do we have? We have 512 minus 3 times the number of photos taken, which is X photos. And that's our rule. This is our function rule. This is our equation. Y equals 512 minus 3x. If you prefer and you want to say, oh, that's y equals negative 3x plus 512, that's fine. I prefer that way, but we'll get into y later. Why? Get it? Because y next. Hey, look! I've kind of do this in a weird order, but that's okay. We've got our axes, let's graph it. The first step in graphing is always to label your axes so you know where to put your information. We've got our independent and our dependent variable. Our independent is number of photos, so let's go ahead and label that. Photos taken. We go 1, 2, 3. And then the memory left. Ooh, boy. Okay, guys, I'm going to show you a quick math trick. So notice how our y's are very high. They're in the 500s, but they're all close together. So it doesn't make sense to make this to make our points so close and be like, here, 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 because that's not a very good graph. That doesn't show you a lot of what you're going to do. So we're going to zoom in on our graph a little bit. We're going to do this fancy little cut the jugular of it or whatever. And what that is, it's basically saying, hey, you know what? We're going to take our x-axis and we're just going to scoot it up the graph for a while and just look at the top part of our graph. So we're going to start labeling our megabytes here as 1, 2, 3, 4, 505, 1, 2, 6, 7, 8, 9, 5, 10, 1, 2, 3, 4, 5, 15. So instead of having it like super to scale, we just kind of cut it and then zoomed up to the top. All right. So when we take 0 photos, we have 512, 11, 12 up here. When we take 1 photo, we've got 509. 509 is here. And when we've taken 2 photos, we got 506, or 2 up 506. And finally over 3 up 50, 2, 3. Nice. Now we want to determine, is this linear? Let's look at our graph. Does it represent a straight line? Well, let's connect the dots, literally connect the dots. Yes, they all fit. Excellent. So good. So yes, since the points make a line, this is a straight line, then yes, this is linear. Done. Okay? In order to be a linear function, they need to have all the points line a line. Remember, x goes side to side, y goes up and down. Yeah, a function is a rule. Ta-da! All right, well, have a great time on your homework.